Um, Hi everyone, thanks to be here. My name is Mathieu and I'm presenting with David. Today we're going to present you about BITCLUSTER. That is a tool that we're going to release at the end of the talk. In fact, it's already on GitHub, and we released the database also. It's the tool that is able to de-anonymize some actors or some entity in the Bitcoin network. So first of all, who are we? I am Mathieu Lavoie. I work as a pen tester for a large Canadian financial institution. I'm also a close friend of the NorthSec organization, security conference in Montreal. And I'm presenting also with David Descarriers.
Yep. Hi, everyone. So I'm an assistant professor in Montreal who've been looking at the cybercrime and online illicit markets for a number of years now.
All right, so we're going to go, the talk is pretty long, so we're going to go straight to the point. So first of all, we're going to start with a little bit of cliche, what this talk is not about. Definitely, this talk is not about creating another Bitcoin currency is broken clickbait title. I'm sorry. We're not going to divulge, or not going to tell the names or owners of Bitcoin wallets into the network, at least not all of them. And we're also not going to show you a way of magically retrieving the private key for a Bitcoin wallet and then spend all the money as you want. Sorry, guys. What this talk is about is a lot of detail about how does Bitcoin works. When you're going to understand those concepts, you're going to understand the limit of the pseudo-anonymity of Bitcoin. So you understand how the transaction works, why we are able to get some details about the node, how we are able to correlate all the data that is public and to find interesting stuff into this network. That brings us to the limit of pseudo-anonymity. Well, yes, Bitcoin is anonymous, into quote, but there are some limits. So we're going to present those limits, and we're going to present also if you don't use well the tools, if you don't use well Bitcoin and how you don't understand how it works, how you may get caught by our tools. And finally, our tools, BITCLUSTER, we're going to do the tool release. We're going to present the tool with a small demo, explain how does it works, what does it do, and also what you can do with this. So the case study will be presented by David. So the Bitcoin auto in parts. I'm sorry for those who are cryptography expert, but I need to give some basic details about how does it work so everybody will be able to understand the rest of the talk. Some details that we're gonna show are, it's supposed to give you some information about how we achieve the anonymization of the network. So if you want to participate into the Bitcoin network, you need an ID, and an ID is an address. It's an address where when you can receive money and you can send money. To get an address is pretty simple. You need to generate a pair of keys, a private and a public key. The public key will be encoded and will be encoded as an addresses. So in summary, a public key is an addresses. It's just represented as a simpler representation of it. We've seen about approximately 146 million different wallets. And as I said previously, those wallets or addresses are generated by the user itself. So on your own machine with OpenSSL, with your own Bitcoin client, it's not a central authority that delivers the addresses. It's the user that generates them directly on his machine. And for the rest of the talk, we're going to talk about wallet and addresses. Both mean the same thing. Now that you have an addresses and you generate and you're pretty proud of it, now you want to use it. How are we going to be able to use it? Well, we have to make a transaction, and the transaction will be included of what we call a blockchain. So the blockchain is, in the simpler representation, like for this talk, it can be seen only as the public ledgers of all transactions that have been made up to there since the beginning of Bitcoin. It stores transactions into blocks, and the new blocks is created every 10 minutes. That means that new transactions are included into the blockchain every 10 minutes. The interesting part now, the transaction. So now that you have an address, now that you know how transaction gets validated, what is a transaction actually? Well, a transaction is composed by input and output. Input are money that you own, that you want to spend, and output is where you want to send the money. Sorry, I'm just gonna take my glass of water. All right. An input is a reference to a past transaction where you receive money. So for example, David sent me 3 Bitcoin 2 months ago. When I want to spend those Bitcoin, what I do is I tell the network, remember when David gave me Bitcoins? All right, now I want to spend it and I want to send it to someone else. So what I do is I refer to the transaction where I did receive the money as in the input, and to prove that I own these addresses that did receive money, I sign this input with the private key associated to the addresses. So you may remember that when you generate an address, you have the public key and the private key. You keep the private key for yourself for obvious reason, and you encode the public key to get an addresses. So you take the private key associated to the addresses, you sign the input, and the transaction will be considered as valid. So how can we achieve the de-anonymization with those information? Well, as you may guess, already it's related to private key and to transaction, but we're going to go deeper into that. The title is misleading. Is not the Bitcoin de-anonymizer, is the Bitcoin de-anonymizer for people who don't know how to use Bitcoin. Like, for like a little example, if you are asking for help on Stack Overflow to create a new crypto markets named Silk Road, usually you're not good to use Bitcoin. So in this example, I forgot to tell you that in the transaction you can have multiple input and multiple output. So you can send in one transaction money to different person, and if you want to send money, a big amount of money to someone, and you don't have this money in addresses, you can use multiple addresses that you own and merge it together, and then be able to pay your debt. So in this example, I take a transaction where I did receive 3 Bitcoin, and another one where I did receive 6 Bitcoin, and I'm paying someone 9 Bitcoin. Well, in this case, there's some information that leaks. What I mean is you did use 2 different addresses at the same time and were able to sign both of these addresses with their each private key. So you were able to sign the private key from the addresses that have 3 Bitcoin, and you were able to use the private key for the addresses that you have 6 Bitcoin. So what you're telling here is that you own both of those private key. And as you may recall, a private key is private. So that means that if the transaction was validated by the network, that means that the person that did the transaction had 2 of the private, both private key. So in this case, we are linking those 2 addresses to an entity or an actor of this network. And what happened if you reuse addresses over and over? Well, actually this happened. So here are 3 transactions with 2 input, and 3 input. And what I can do with this, and I'm able to know that all of these addresses are related to the same person because they are reusing addresses. So here, there's a reusing addresses between 2 transactions. So I'm able to merge those both transactions. And I'm also able to do the same thing with the other addresses. So it's still using another addresses on 2 other transactions. So I have the full link here. I'm able to merge all those 3 nodes to a big node. I'm going to give an ID. In this case, will be the ID 2345. So that's how we're gonna achieve to create all the to cluster all the addresses into nodes that we are representing identity or actor in the network, and then after we can recrawl it back and see the money movement between those actors. So instead of seeing transaction, we see money movement in blob of addresses that are representing identity or person into the network. So in summary, the assumption made to do the tools is transactions are signed with private key. Private key are private. And one and only one entity can or should know the private key. Ergo, all the addresses that you see on the previous slide are necessarily owned by a single entity, actors, or person, as you may call it. So why is this possible is because people are reusing addresses over and over instead of generating new addresses, as you should do. And in this case, the first way of blowing a cover is pretty simple. So we take the same example again, the 3 Bitcoin and the 6 Bitcoin transaction. But instead of sending money, instead of sending 9 Bitcoin to an addresses, I will send 8 Bitcoin to an addresses and send back the change to an addresses I already own. So in this example, the 3 Bitcoin addresses is the same as the one that did receive the change, the 1 Bitcoin change. And when I will use the 1 Bitcoin change in another transaction in the future, I will also taint other addresses and taint it to the node that already contains addresses. The solution number 2 to blow your cover is to give the same addresses to multiple people. So for example, I want to receive here a transaction from Joe, a transaction from Fred, and a transaction from David. I'll give them the same addresses to those 3 persons. So I'll give the same addresses to David, to Fred, and to Joe. And they all gonna send me the money. And when I will reuse the money I just received, I will also taint it with multiple addresses and be able to correlate all those addresses into a single node. What you should have done is this. This is how not to blow your cover. So for each person you want to receive money, actually what you do is you generate a new addresses, because you can generate as many addresses as you want, and you should generate each time a new address, each time you make a transaction. And when you're gonna spend the money you receive, you will not taint each other. You will not taint all the addresses. You will just taint a part of the addresses, and I will not be able to merge all those nodes into one big node that containing a lot of addresses. Here, we're talking about an all wine that was never open. That means that we're not the first one to think about this concept. It has been discussed in the in white papers and academic research since 2011. A good paper about it is the one from MIT about the clustering. That is the title is on the screen. And also there's a website that I didn't know until David told me. I think it's 3 months ago. It's called Wallet Explorers that did approximately the same things, but not in the same way. So they are clustering all the addresses together, but they're not giving the same information. The problem with those tools, or those 2 achievements, is, for example, for the white paper, the research has been done on only a small part of the network. So they take a really, really small part of the Bitcoin transaction and they do the research on it. So it's not part of all the Bitcoin transactions that have been done up to date. Also, proof of concept code is not available. Raw data of the result or the input is not available either. And any information about the concrete methodology is not available either. For Wallet Explorer, it's a closed source website. You can only query it through the web, so you don't have any access to the raw data. It's not able to download it. It's only representing the node, the raw transaction nodes, so it's not grouping them, the transaction, the money movement per node. So you won't see, like, for example, Silk Road sending money to empty GOX and back and forth. You'll just see Silk Road raw transaction. But the tagging is quite accurate on this website, so they did a really good job on tagging. But it's not you cannot have access to database, you cannot have access to raw data, you cannot have anything, and it's closed source, so you cannot like do whatever you want with this. That's the reason why BitCluster is there. It's open, it's open source, it's free, and the database will be released. It's already available on torrent, so it's 200 gigabyte of data representing all the addresses that have been seen in the network and all the transactions regrouped by node into a database, so you can query it and take the information as you want. And we encourage you to customize it, to make millions of queries directly to the database, and to expand it to something really, really cool. So it's up to you now. So a bit about designing BitCluster. It started with a good intention, a good code design and everything, and it wasn't able to scale. So I had to scrap everything out and do something quick and like really, really efficient, but not really, really, really nice to see. So the code is pretty, really difficult to follow, but I've been profiled and optimized over and over and over. So the concept is pretty simple. It's basic math. The data is public. It's only node and addresses. You represent it in a graph. It's easy. It totally fits in memory. Well, why did somebody didn't do it already? This is where the fun parts begin. Hitting a wall round A. At this point, I was already accepted in a conference with a tool release. So I started like a Sunday afternoon and said, oh, well, I should begin my tools. It will be easy. At the end of the day, I will have something that will be working. So I started with the blog, take each transaction of the blog, take each input, calculate the Bitcoin addresses, put it in a graph, and actually, this happened. Yeah, that's pretty accurate. So I have been accepted in the talk, presenting a tool that doesn't work. So I have to do something about it. So that's what we do. So round B, okay, now I have to optimize the code and see another method of calculate the addresses. I did something that seems to works, but all the addresses that generated does not exist in the real life. So I have a problem somewhere. And finally, I was able to do something that the final recipe here was I need two computers. One for the crawler in Python, one for the hosting the Mongo database. I'll create partial graph of 5,000 blocks in Python. I merge them into all the big graph that is there in the DB. And while it's merging the data in the DB in the full graph, I start again building the new graph in Python while it's still inserting in the DB. And I repeat step 2 to 4 for a week at least. But you don't have to do it again because the database is now available publicly that you can just download it like within the torrent. So it's approximately 20 gig of compressed text in a torrent that you can download and install. So you don't have to wait a week now. So the minimum system requirement for BitCluster is the fastest processor you can afford, 500 gig of SSD. And SSD really, really important. You're not going to do anything if you store it in HDD. 32 gig of RAM and 64 is way better. Python 64-bit. It's really important because you will reach the 4 gig limit in the 32-bit process. A week of free time. As I said previously, you don't need that anymore since the database is available on the internet and you can download it. But if you want to recreate it from scratch, you need a week of free time and multiple table flips. So the total stat is we see up to date 146 million different addresses or wallet. We see approximately, more than 58 million different nodes are representing person or actor in the network. So that make an average of 2 to 3 addresses per user. The largest node with the node with the most wallet is, with no surprise, empty guts. So 12 million addresses is associated with the empty guts node. And the total amount of transactions, so in our transaction DB, the number of rows is 387 million rows in the transaction database. So the DB schema is quite simple. You have the table addresses. It's the wallet addresses and the node ID associated with this address. And in transaction, you have the source and destination node ID. So where did the money come from and where did it go? You have the amount in BTC, in Bitcoin, and converted in USD using the conversion rate at the time that the transaction have been made. And you have also the date and the block where this transaction happened. So it's now time for a small demo of the tools. So sorry guys, I did record a video because live demo always fail. So it's gonna be a video. So I think I just have to press next. Start, okay. So first of all, you need to search for an address. So this time I'm gonna search for Satoshi Dice addresses that you don't see on the screen because I've been cropped. It's there, but not there. And you find an address associated to Satoshi Dice. You punch it into BITCLUSTER, and you find it. It takes approximately 5 minutes to compute, and you get the result. So we already have the result for you. So to prove it, we're going to search for the addresses that we get through Google, and you see that it's there. And you all see also a lot of addresses that start with 1 dice. That is a prefix for Satoshi Dice, so that it's indicating that the clustering algorithm is quite efficient. For each node, you have the total income, you have the total outcome in Bitcoin and USD. What we see here is there a difference of 5,000 Bitcoins. So even if there's 2 possibilities. One, Satoshi Dice only made 5,000 Bitcoin money out of it, or they already transferred the money into other nodes. And you see the income section, so you can see where the money came from. So you see the node ID. You see how much money this node sent to the current node, to Satoshi Dice, in US and Bitcoin. And you see in how many transactions does it make. And you can also group it by date. So you can see by date how many did Satoshi Dice did receive money, so how many transactions, and the amount also in USD. So that's back in 2012. So you see that one day they would receive a lot of money and some transaction. And you can see also a group by amount. So you see the distribution of the amount. So you see there's a lot of small transactions that are being made to send money to this node. And you can see also the raw data of all the transactions associated with that. You also have the same stuff for spending transactions. So you see where the money goes from Satoshi Dice to other nodes. You see also how many did Satoshi Dice send money per day, and what is the amount of money. What we see here, it's around less than 1 cent per transaction. Most of the transactions that are been sent from Satoshi Dice are less than 1 cent US, because of the concept of the game. It makes sense. And you can see also all the addresses associated. Then after, you can just see a random node and click on it to get information. So you can browse through node and node, like just by clicking on different link, and it gives you the same information for the node that that you select. And it gives you also the income group, the spending details, and the node addresses. So this tool is now available on available on GitHub, so you can clone it, and you will have the full web interface if you download the DB also.
So for the second part of this presentation, what I want to do is move to case studies and kind of give you an idea of how you can use BitCluster to just learn more stuff about the actors in the Bitcoin network. And because I'm a criminologist by trade, I'll be talking about fraudsters, hackers, carding, and other stuff like that. So we should be having a lot of fun for the next about 20 minutes. And I'll show you that sometimes, yes, it's true, crime does pay, and I'll give you some examples of when that happens. So the first case study I want to talk about is ransomware. So we've all heard of ransomware. It's a type of virus that encrypts the files on your computer and then asks you for money to get it back. And actually, you don't get your files back. You only get decryption keys to decrypt the files that have been encrypted on your computer. And you know, these guys are really serious because, you know, they're using military-grade encryption to encrypt your files. And so the ransomware business is actually a pretty good business to be in for those interested. It does make a lot of money in some cases. And why does it make a lot of money? Well, first of all, it's because the ransomware guys are only asking for a small amount of money for each victim. So they're being kind of reasonable, and they're telling you, well, are your files worth $500? In many cases, people are going to say yes, and they're going to pay up the money. The other thing is also that they always have a timer on these ransomware, and they tell you, well, you have 48 or 72 hours to pay us the ransom. Otherwise, the price of the ransom is going to double, or we're going to destroy the decryption keys. And so this means that the victims have to learn what the hell Bitcoins are. How do you buy Bitcoins? How do you pay someone with Bitcoins? How do you decrypt your files? And you only have a few hours to do so. And so this is why kind of ransomware works. And so why would BITCLUSTER be useful to learn more about ransomware? Well, we can ask, if we give it, for example, a wallet that was where a ransom was paid, we can ask BITCLUSTER if it knows about more wallets that are associated to that one and see what other wallets are into the same node as the ransom wallet. And so we can ask BITCLUSTER to give us, for example, time series analysis to see how long the ransomware campaign lasted, how many victims there were, how much revenues were generated through this. And so for this talk, what we did is we asked a few of our friends in the InfoSec community for wallet addresses that were related to ransomwares, and I thank them all for sharing some. And we got a sample of about 60 addresses that we divided into kind of 3 very broad types of ransomware. And so what I call the first type 1 ransomware is here you have the cumulative revenues of this ransomware. And what it shows is actually a pretty successful ransomware, which made about $611,000 in revenues. And I don't know why I kept the cents, but it's still, I guess every penny counts when you're earning money. And so what we see over here is actually kind of interesting, which this ransomware made about 1,100 victims over its lifespan, and that's about 20 victims per day, and that's about $10,000 that were earned every single day. And I don't have to tell you once again that this is with very low cost in infrastructure, and of course, very little taxes to pay at the end of the year. And so here we see that about 80% of the revenues were generated between November 2nd and November 24th. So most of the money was done within 3 weeks, which means that if you want to react to these ransomware campaigns, you have to be very quick and very efficient if you want to stop it from propagating. And ransomware can be very personal, and the one that I just presented is actually for me. A research center that I was working at was actually hit by this ransomware, and so we weren't sure if we were going to pay to get the files back or not. Of course, there were no backups at the research center. The security people weren't sure we should pay because it would encourage more crime. And finally, we decided, we're just going to do it. And so I went on localbitcoins.com, find someone who was willing to sell me Bitcoins really rapidly because there's this timer going down. And I go and meet this guy who looks, kind of like the guy I have in the slide over here. And he's just in sweatpants, and he's just waiting at our local Bitcoin embassy for people who have been hit with ransomware and just selling them Bitcoins at a very high price. And so apparently you can also profit from a very profitable business if you're into the Bitcoins. And if you're wondering, in the blue box over there, that's me paying a ransom about 2 years ago. And so there's other types of ransom, of course. The type 2 ransomware is also very good at making money. The second case is a case that made about $170,000 US. But this one was kind of different from the first one. First of all, because it lasted a lot longer. It was active for a couple of months. And the other interesting thing is also that it never stops making money. It just keeps on making more and more money. And our guess is that this ransomware actually continued well after the end of this graph, but they kind of changed their wallets, so we kind of lost track of them. So this is perhaps kind of more sophisticated scammers who knew that you could perhaps be traced with Bitcoins. Maybe they foresaw that BITCLUSTER was coming a few years later, and so they switched up their tactics and how they were using their Bitcoins. And finally, we have the type 3 ransomware, and these are the guys that are really sophisticated, that really frustrated me, because we only had one payment, 1 day with one victim. And so that meant that they were smart enough not to bring all of their money together in one transaction, only use, as Mathieu was saying, one input per transaction. And this means that we could still use BITCLUSTER to follow the money around, but I can't just amaze you by telling you how much money they've made in a couple of weeks. The second case study I want to talk about today is online illicit markets. Now, I'm sure everyone here has heard of these online illicit markets. They're on forums, they're on chat rooms, they've been around for decades, and you can buy pretty much any illicit products or services online on them. Over the past 5 years, there's been a new generation of online illicit markets, and they're called crypto markets. I'm sure some of you may have heard of Silk Road. Yeah? At least one person. That's good. So, well, these new generation, these crypto markets are really interesting because they're a lot more secure than the old online illicit markets for a number of reasons. And one of these reasons is that they're using technology to help them secure themselves. And so they're going to be using PGP keys for communications. They're going to be using the Tor network, whether that's secure or not, we can always talk about it, but at least it gives you more security. And of course, they're going to use Bitcoins for all of their payments. And at first, crypto markets were really into drugs, so it was kind of the place where you could go online, buy drugs, and get it, shipped by the mail to your own house. But over the past few years, they've actually diversified a lot, and right now we have about 50% for listings that are for drug-related items, and the other half is for something else completely different. We're talking about carding, hacking, financial fraud, lots of services. If you want to buy a proxy, if you want to buy a Netflix account for cheap, they have them for like $5. So lots of very good offers on these crypto markets. And one of their main feature is that the customers, here you have an anonymous customer, don't actually pay the vendors directly. What they do is they take their money and they pay the marketplace and they put it into escrow. And when they put it into escrow, the market is going to hold on to this money until you receive the good or the service you've purchased. And once you do receive it, then the money is transferred all the way to the vendor. And what this means is that if the crypto markets are very smart about how they manage these Bitcoins, they're going to have one wallet for each of their customer, and they're going to separate everyone's money and not put it all in one big pot. And you can guess from why I'm talking to you today is that is not the case. And so using BITCLUSTER, what we can all actually do is kind of bring all of these wallets together and follow these crypto markets and try to understand a bit more about how they behave. And so I'm going to give you a few numbers and show you kind of what you can do with this. And the first thing that's kind of interesting to me is using BITCLUSTER to learn how many transactions there are on crypto markets. And so here you have the case of Silk Road 1, the first crypto market that was active between 2011 and 2013. And what we see over here is that the number of transactions sharply rose over time. So we went from about 500 transactions per day all the way to 3,000 transactions per day. So once again, it's not this big thing that was selling millions of transactions per day, but still interesting to see how many people were involved, how many people were putting money into this Silk Road to buy drugs and other stuff as well. Perhaps even more interesting is when you look at the revenue. So how many Bitcoins flew through these escrow payments? And here you see once again that the numbers about quadrupled over the years. So they went from under $200,000 all the way up to $800,000 at the end of Silk Road's lifespan. And at the end, the graph ends because that's when law enforcement just shut down Silk Road. And it's really interesting if you look at this Silk Road page on BITCLUSTER, you're going to see that it's generating a lot of money. And then just one day it just stops and goes down to almost zero from one day to the other. And here, when you look at this, we see that we've generated overall about $196 million. The FBI was saying when they began $1.2 billion, and then they realized that this was totally false, and they brought down the estimate to about $240 million. So we're pretty close to what the FBI has estimated from the seized servers, and I guess we're missing a few wallets from this because, well, nothing's perfect, but we still get a very reliable idea of how much money and how many people were involved into this community. And what I've presented so far has been very macro level, but it's also possible to go more at the micro level and to look more detail about the customers of Silk Road. Who were these people and what were they buying? And the one thing that was of interest to me was looking at, well, how much are these people paying when they're making a purchase? And you see here that about 91% of all the transactions, all the money that was put into Bitcoins was under $500. So probably these people were, in many cases, buying small amount of drugs, maybe social supply, but still, from what we see from the number of transactions, it was fairly small transactions. There were still actually transactions that were raised over $1,000, and these are for like kilos of cocaine or kilos of weed, because you could buy such big amounts on these crypto markets. And these are very small, but you have to remember that even though it's a very small proportion, it's still thousands and thousands of transactions, if not more. And when you look at the revenues, well, you realize that when you just add up the revenues and you see where the revenues were coming from, about half of the revenues were coming from these small transactions, so under $500. But the pie chart really changes, and you see that these big transactions, where you're buying massive amount, either of drugs or whatever else, are very important, about a third of the revenues that were generated. And so when you're trying to understand how these markets work, what are people buying, it's actually not only just small quantities of drugs or small amounts of whatever hacking software. They're going to be buying some things that are very expensive. And that's something that I found in my own research in the past. In my own research in the past, what we did before we had BITCLUSTER is we look at feedbacks. So most people, when they bought something, left feedbacks, kind of like you do on Amazon or eBay. And here you have some guy talking about a purchase of Coke that he made. And apparently his Coke had a strong bubble gum taste. And apparently that's very good because he gave it a 5-star out of 5. And so you have a price, you have a date, you know the product, and so that kind of lets you kind of add it all up together and kind of multiply the number of feedbacks by the amount that you paid for, and that gives you kind of size and scope of crypto markets. And that's kind of what I did in the past, and that's what many colleagues of mine have done also in the past. If you look at Silk Road, and here I wanted to show you kind of the differences between BITCLUSTER and what we had before. Perhaps one of the most exhaustive study looking at feedbacks was made by two guys, Suska and Kristen, that was published back in 2015. And they did an amazing job of bringing all of this data from many, many crypto markets together to kind of find what is the overall size and scope of crypto markets. And here you see the bars are the Suska and Kristen data, and the line is the BITCLUSTER data. And you see that we see a lot more Bitcoins going through this crypto market, and this is only for Silk Road 1, than that we saw in the feedbacks. And now you could either hypothesize that actually feedbacks don't tell the whole story, that there's actually a lot more drugs being sold on Silk Road than you could see with the feedbacks. But my own guess is that actually people thought that Silk Road would be around forever. It was this magic community where everyone was fun and everyone liked each other. And so people actually, when they were buying, for example, $100 worth of drugs, they would put in $200, telling themselves, well, I'll just keep 100 in there, and when I need more drugs, I'll just go back and it'll be there for me. And so my guess is actually the difference can be explained because there's this gap where people were leaving money on Silk Road. At the end of this graph, what you don't see is that the police shut down Silk Road, the dream ended. And so there were a lot more crypto markets that were launched later in 2014. And here you have a combination of the revenues from all of these crypto markets brought together. I think there's about 6 of them. And what you see is that people, I think, were a lot more scared to leave money on crypto markets because they thought they can be shut down at any point in time. And this is why you see that the correlation between our data and Suska's and Kristen's data, it's much closer on that graph. And very interestingly, you see at some time intervals, especially on the left, that there's actually more money according to the feedback than we could find in BITCLUSTER. And one of the things that I've suspected was that they were fake feedbacks. I know this is very shocking, but that the crypto markets were actually generating fake feedbacks to make it look as though there were a lot of activities on their crypto markets. And so this would suggest, at least on the left where you see there's more feedbacks and revenues, is that these markets were generating these fake feedbacks to make it look as though there were a lot of money. Though it did increase over time, and we ended up about where we were about $800,000 a day in total revenues. And so because we want to save some time for questions, I'm going to go very quickly over the main takeaways for this talk. I think that the one thing to remember is that the Bitcoin network never sleeps. It's always collecting money. The blockchain is always there. And when you're looking at what Suska and Kristen did, they did an amazing job, but it took a lot of time, a lot of energy, and a lot of money to collect all of those feedbacks. Mathieu and I were just 2 guys playing with the blockchain, and we managed to replicate some of their results, not perfectly, but still some of their results with very, very little resources and in a much limited time frame. And so I think it's very important to notice how important and how useful the blockchain can be. And one of the most interesting feature, I think, is that you can go back to the future, if you will, which means that even though you never knew that Silk Road existed when it was online, even though you didn't care about Silk Road when it was online, 5 years later, 20 years later, you can go back in time. If you have at least one wallet from Silk Road, you can go and investigate what was happening there, what were people spending, what were people receiving, and you're not limited by time. The feedbacks, once the page is taken down, there's no way to get it back. It's gone. We're not going to get it back. With the Bitcoins, however, it's very interesting that you can just go back in time and just play with the data as much as you want. And finally, I think it's very important to stress this, that you always have to validate. No matter what finding you find with BitCluster, you have to find alternative sources of data to validate your results. If you look at my Silk Road 1 data, for example, the headline could say, well, you know, Silk Road was twice as big as we thought before. I don't think that was the case, but you could still, you would need to validate whatever results you get. And it's the same with the ransomware. If it says a campaign ended on a single date, maybe they just change their wallets, and you have to go and find answers elsewhere. And so what's next for BitCluster? Basically having real-time automated database updating. So right now you have to do it manually, so it's maybe more of a pain. We're hoping to have that down so it's pretty much live. So when you're running it on your own computer, kind of have it up to date at all time. The labeling of nodes. So right now all the nodes are only known for their numbers, and so it may be difficult to remember that 2146562 is Silk Road. It's easier to have names. And also have some visual graphs. So basically just, you know, point and click and just click on a node and see where the money is coming from, where it's going, kind of more visual aspect to the tool. And finally, perhaps a hosted version of the tool. I'm saying here if we get a quantum computer at some point. It's just that it's very, very memory intensive and CPU intensive. And we could host any query that you guys would have, but we can only have like 8 queries at the same time. So it's a very limited tool. So we'll see what happens with that in the future. And so the URL everyone has been dying to see. So the tool is online, the database is online as well. You can download it all. It's free and open source on bit-cluster.com. And that's it for us. If you guys have any questions, we'd love to hear them and share what we've learned. Thank you. Maybe if we can open the lights so we can see if someone has their hands raised.
Do we want to use the mic
Thank you.
for the questions?
So, oh.
Sorry. Yep.
Oh,
go ahead.
yeah. Can I start?
Sure. You can go back.
So you guys mentioned that because of the difference in the FBI estimate for the size of Silk Road and your BitCluster estimate, there was like maybe an extra like $50 million in escrow. Isn't it possible that later markets were just stupider and had fewer wallets going on, and that, you know, people still kept the same amount of money in escrow?
It's possible. I would say that there's been so many crypto markets that were on and off for the past few years that I would never leave any deposit in any crypto market because it could be taken down at any time.
Right.
I didn't talk about exit scams where the markets just steal everyone's money from their deposits. So I really doubt that there's a lot of money being held in these deposits. What people usually do is if you're buying for $100, you put in $100, pay with it, and then you're out. So I guess that's why you see the smaller difference between the two.
Okay, thank you.
Oh, welcome.
Hey, so I know that doing computation with large graphs is a really hard problem. So I think it's great that you guys could get this to run at all on such a gigantic graph. Have you been thinking about any interesting ways of optimizing it so that it'll do the computations you want faster?
Can we open the mic? It's not.
Well, yeah, there's a way that you can remove some nodes that are not really interesting. Usually to make a query on a really big node is approximately like 3 minutes for Silk Road. So it's not that long to do the optimization. What is long is when we host it, the same query is made over and over and over. So what we're going to do if we're going to host the tools, we're going to put some caching. So for example, like it's never changed in like at least a block for at least 10 minutes. So we may be able to reuse data that have been already computed to show the same result to multiple users. So we're going to do something related to caching to possibly be able to host it somewhere. For the graph analysis, the main problem is the number of nodes that's still there. So even though the Jigsaw algorithm will not be able to scale it on 58 million of nodes, so by now I don't have any situation. I think we're going to be limited like to browse until 3 or 4 level. So maybe not be enough to bypass the long-range scheme, but it may be able to, depending on the long-range scheme. But to optimize on the research into the graph, I don't think that we're gonna be possible. But to host the tools, we're gonna put some caching. So because the same query is made over and over and over again, so we don't have to compute and just give you back the result in real time.
Hi, thanks for the talk. So it wasn't really the focus of your talk, but moving from just nodes with numbers to actual people, it seems like it'd be the actual value in this. So have you guys actually talked to anyone or started doing that?
Yeah, I think that's the whole point. The tools have the opportunity that you have to de-anonymize one addresses out of 1,000 or 100 or 1,000. So the main advantage of the clustering is you have to find only one addresses to map it to a real identity, and then you map a whole bunch of addresses to an identity. But yeah, I agree with you. The main concern here is to put identity on nodes, and that's it's the next stuff that's going to do. You may want to go with Wallet Explorer and see, because their tagging algorithm is quite good, and then you can use the addresses that you find associated to node and punch it into BitCluster to have more information about those person. Is it fine? Is it answering the question? Yeah. Okay.
Thank you. Also, can you talk a little bit more about the two issues you mentioned mid-talk about the change, or about having multiple people giving to one? Because it seems like they didn't quite understand how that helps you de-anonymize. I understand, like, multiple into one, you can tell the private keys belong to the same person. Like, why is it a problem if multiple people give to the same address?
Yeah, the problem is, for example, in transaction A, you'll associate address A and B to the same person, and then it sends back the change to address A. And then if you reuse the addresses A that you received the change with, for example, D and E, I will be able to tell that you own A, B, D, E.
But why is it a problem if 5 people give to the same wallet?
Okay, if 5 person send it to the same wallet, is, for example, if all 5 person send it to address A, I may use the output, the first output of first transaction that I've been sent to address A with a conjuncture of address A, B, C. The second one with A, D, E. The third one with A, F, G. And then I taint way more addresses that it should be, and I will be able to regroup all of them together. Is it clear? Okay, perfect. I just want to make sure I answer the question sometime, because as you may know, it's not my first language, English.
Thanks for the talk.
Last question, okay.
I just wonder, have you taken a look at like Tumblr services like Bitcoin Fog, and like, I've always kind of wanted to know where that money ends up, you know? Like, is it going more in, or is it coming out and going into cash from there? I don't know.
Usually, I'll explain it on a more technical way, and then after, if there are like habits or trend, maybe David will be able to answer. The main difficulty is when you put it on a Tumblr, there's a lot of transactions that are being made, so it's really, really complicated to crawl into this graph and to find to find a node is the laundry scheme. You have to find a way of seeing, like, for example, 100 Bitcoin have been put into this scheme, and crawling through all the transactions at different levels, so crawling the graph, and find a place where all this money came back into one node, less the commission of the tumblers. So that's quite difficult, because you need to know the commission of the tumblers. You need to crawl with like pathfinding algorithm through all the graph that is really, really exhaustive, CPU and resource exhaustive. So by now it's a bit difficult to find it. The only way that we may find it is, for example, if the long-range scheme use only like 2 or 3 transactions before sending it back to the node. But I don't think they do it. They do it like a lot of transactions before they send you back the money. Yeah, it's a good system actually. But well, define good, but yes, it's working.
You might have already answered the question right now, but
sorry. We're out of time for questions, but if you'd like to follow up, I'm sure Dave and Matthew would like to take it offline.